Yeah, Camson everyone. This was the last thing that we did. Hope everyone has resolved the questions again. This is something I keep telling you after the class gets over within next day. You're supposed to take a rough paper or something, look at each question and try to resolve. If you don't do that, you will never get that speed. And after a week, when you open the notes, everything will feel completely new. Then you will spend 2 to 3 hours, and then later you will cry, "Oh, I don't have enough time." So that is a difference. You don't need to do great things, super work. You need to do everything consistently. So last thing we did was this. So let's go ahead with a question. So we got a rod here, mass and lintel. Angle theta. The ground is rough. The wall is smooth. Find all normal reactions and friction on the rod. Find friction. Normal reactions. There is one due to the wall and one due to the floor. And the minimum coefficient of friction. So ground is rough, right? So there will be mu also. Mu minimum, so that rod does not slip. Remember the process last time what I taught you? The steps are still the same. Choose your system, draw your free body diagram, then apply forces in the horizontal and the vertical direction, apply torque about any axis is zero because it is in equilibrium, and then solve. The process still remains the same. Others do keep your cams on. Got an answer, type in the chat box here. Try, I'll give you 2 minutes. Okay. We do have different answers, Ishan. I think you are right. Purvaja. Can you find minimum mu, Purvaja? Tell me mu and thing. I remember that one. Friction is mg by 2. Okay, let's see. Step 1. Choose your system. Draw the free body diagram. Your system is the rod. What are the forces? N1, friction, N2, and mg. That's it. There are only 4 forces. Apply F is equal to ma in the horizontal direction. N2 is equal to friction. N1 is equal to mg. System is in equilibrium, so you can take torque about any point. So which point is the best? I will take the bottommost point. Now, when you take the bottommost point, when you find the torque, extend the vector, drop the perpendicular. This distance will be L by 2 cos theta. Extend the N2 vector, drop the perpendicular. This distance will be L sin theta. You should know your perpendicular distances to calculate torque. Then torque about A will be torque due to N1, torque due to friction, torque due to mg plus torque due to N2 is 0 because it's in equilibrium. Friction ka torque is 0 because it is passing through. N1 ka torque is 0 because it is passing through the axis. Mg ka torque is mg, perpendicular distance L by 2 cos theta. And if this is the axis, this is the force, the body will try to rotate anti-clockwise. I hope that part is clear. You should be clear with the directions plus k cap. Similarly, N2 will be sine theta minus k cap. From here, we get N2 is equal to mg by 2 cot theta. And N2 is equal to friction. So this is also the F ka value. N1 is already mg. So we know friction is mg by 2 cot theta. Now friction is always less than equal to mu into N1. N1 is mg, so mu must be greater than equal to cot theta by 2. Yep, that's your minimum mu. If anything less than this, there the rod will slip. Have a look at the steps. Did we do anything new? FBD, force, torque, solve. The game is still the same. Any doubts on this? Anyone not convinced with the free body diagram, the force equation, torque, anything you're not clear? Next one. Next one. So we have a wooden plank here. It's a rough plank, mass M, length L. So this is supported by a block. This is your support block. So this is x is equal to 0. So initially block is at center L by 2. This is the corner, x is equal to L. If you don't have the support block, what will happen? The rod will look, isn't it? This will fall down. It will look like this. So the support block is making sure the plank is horizontal. The ground is smooth, but this plank is rough. So this surface is rough. Friction is mu. Now what you did, you started pulling this block slowly with a force F. Right? And the question is find the work done by the force to pull the block out. Is the question clear? So meaning when you're pulling the block out now, after some time block will come here, after some time block will come here, finally the block will come out. So you're dragging the block out slowly from under the plank. Plank ka mass is m, block ka mass is not given, you don't require. Length of the plank is L. So yeah, the friction between the plank and the block is mu, ground is smooth. F ka value we don't know, it is pulled out slowly. So that is some F. How do we do this? Try. I'll give 2-3 minutes. This thing is hinged in left side. So the left side is fixed, that can't move. Hmm. Hmm. 3/4 mu mgl, wrong record. That's not the answer, Ansh. First you need to figure out the force. नहीं record. अभी देख 3/4 है तो 3/8. क्या कर रहे हो? Ansh, did you try to give the exam today क्या?
हाँ सर।
कुछ तो हुआ रे, तेरा सबमिट नहीं हुआ.
पूरा जीरो शो कर रहा है।
हाँ, एक बार वापस ट्राई करो, बाद में देर रीटेस्ट का ऑप्शन. चलो, let me help you. Step 1, draw your free body diagram. Now, but this time, draw the free body diagram and the block is at a distance x. Since it is moving, let the block be somewhere here. Let this distance be x. Now, if you draw the free body diagram of the plank and the block, you will notice this. Look at the forces. We have a hinge force, Ny. We have Nx. We have N. This is the normal reaction between the support block and the plank. And there is also friction. Friction would be this way. And you have Mg. Don't forget, there is a friction between this thing. So if you take the same thing with the support block, normal reaction will be this way, friction will be backward, and force will be this way. You getting it? Right, Vihan. Is this FBD clear, everyone? So since the block is moving slowly, acceleration is 0. That means F is equal to F max. Why F max? Because it is slipping. So there is a sliding between the block and the plank. So this friction is maximum. Then let's take torque about the hinge. So if we take torque about the hinge, we have torque due to Nx, torque due to Ny, torque due to Mg, torque due to N, torque due to friction is 0 because plank is always at rest. Nx is 0, Ny is 0, F is also 0 because all these three forces are passing through the hinge. This distance is L by 2 and this distance is X. So this torque will be Mg L by 2 minus K cap. This will be N into X plus K cap. So normal reaction is not constant. So N is Mg L by 2x. The more you pull the block outside, the lesser the normal reaction. So N is changing as a function of 1 by x. So once you got this, you are done. F max will be mu into N, which is mu mgl by 2x. This is nothing but the external force F. So work done is integral F dx. Mu mgl by 2 integral dx by x. X ka values will go from L by 2 to L. Dx by x is ln mu mgl by 2 ln x. Limits will go from L to L by 2. That is ln L minus ln L by 2. Mu mgl by 2 ln 2. Check. That's your answer. Normal reaction is not constant here. Have a look at the steps. So this is a pretty good question. So if you see have NLM, we have friction, then we have torque, and then you have work for energy. 4 chapters. Is that clear, everyone? Next one. Next one. Any doubts on this? Sharman, Surya, Puruja, clear? Ojas, Niharika, Devansh, Ansh, clear? Ahana, got this? Adi, Arush, great. Next one. We have an L-shaped rod here. Mass M, length L, mass M, length L. It is an equilibrium. Phi and theta, system is in equilibrium. It's an L-shaped rod. Now, this is still fine, standard 1. Same thing, you could also do this with a semicircular ring. if you have a half ring, I'll give you that as an homework, you can try. So if you put one end here, something like this would be theta. So theta is the angle between the vertical and the diameter. Both the questions are based on similar concept. Let's try this L-shaped rod. If you got the idea, you can try this ring as a homework. I think this thing comes out to be theta tan inverse 2 by pi ऐसा कुछ आएगा. I think so. You can verify the answer. Let's get the L-shaped rod. If you actually take an L shape now, this can't be like this. You won't get a rod like this. It will swing and it will be some weird position like this. It's not 45. इतना अच्छा आंसर. Harika, right. Try that semicircle thing also. Anyone else? We have one answer so far. You guys remember I taught you this in center of mass. Whenever you suspend a body, the center of mass always lies just below the point of suspension. Yeah, do you remember that was a property of a center of mass? And I told you we will prove that here, but you know the property. Daksha, you're pretty close, right? Okay, Ariman, I think you got it. Get this thing. The other one also try for the half ring. The standard result. The first one is still fine. Shana. Let's see. So, first thing, if you draw your free body diagram, you will observe what are the forces. Ny, Nx. Agreed. Now, my question is, if you take torque about the hinge, you have torque due to Nx, you have torque due to Ny, we have torque due to Mg, must be 0 because it is in equilibrium. Nx is 0, Ny is 0 because it is passing through this. Therefore, torque due to Mg is also 0. Now think about it. Suppose if center of mass is here, Mg will be here. Do you think the torque is 0? There's a perpendicular distance, right? If Mg is here, is the torque 0? The only place where Mg can be, so the torque can be 0, is exactly if it passes through the point of suspension. Is that making sense? Right? So since therefore torque due to Mg is 0, right? This is possible. Or you can say this implies, therefore, the Mg vector must pass through the hinge. If you say the force due to a torque due to a force is 0, it means it is passing through the axis. There is no other option. So it is vertical, it passes through the hinge. Must pass through the hinge. Therefore, center of mass is along the vertical line passing through the hinge. So that this is the proof actually. Center of mass is along the vertical line passing through the hinge. Perfect. So I just need to find the center of mass for this guy. So what I will do for convenience, I'll just make it horizontal. Now, how do you find the center of mass for this? If you take this as origin, so this rod ka center is L by 2, comma 0. This rod ka center is 0, comma L by 2. So center of mass of these 2 points is the center of mass, which is L by 4, comma L by 4. And you're saying from this corner to this center of mass, this is your angle theta. Is the diagram making sense? I just made the rod rotate a bit. Right? Yeah, Nx has to be 0. There is no other horizontal force, but that is fine. Getting it? So there, we got it. So if I just draw the picture again, so we are talking about this point center of mass here. You want this angle theta. This length is L by 4. This length is also L by 4. This length is 3L by 4. There you can clearly see tan theta is opposite side by adjacent side. Easy? That's so the main thing is that, it, because I explained it took time, but if it is an exam, you know what happens. The center of mass will be exactly another point of suspension. So same logic here for this. Center of mass iska kahan pe hona chahiye tha? Do you guys remember the center of mass of half ring? So from the center till here, this is the center of mass, na, then that will be 2r by pi. Now we have to use little geometry and solve. This length will be r. This will be 2r by pi. So from there you can figure out the theta ka part. Clear? I think that would be easy only. Just 2r by pi by r. There 2 by pi. Direct आ गया answer एक step में. Sure, everyone. So whenever you have these kind of questions, this is how you do. Find the center of mass and just join them. Any doubts? Next one. Next one. Theta. We have a rough incline. Mu is not given. We have a sphere. Cylinder actually. Solid cylinder, mass m, radius r. So here we have a hinge. So the one end of the rod is fixed here. So this is a rod, mass m and length L. So this is touching the highest point here. That is your center. Basically, those are your normals. So rod is hinged at one end on the incline. The other end rests on a cylinder. And if there is no cylinder, what would happen? The rod would fall down like this, no? The rod will slide and fall down there. So the cylinder is there. On the other end is placed on a cylinder at rest. As shown. All surfaces are rough, huh? Meaning there is a friction between the rod and the cylinder. There is a friction between the cylinder and the incline. All surfaces are rough and there's no slipping anywhere. Find all frictions and normal reactions. Find all frictions and normal reactions. Take some 20-30 seconds. Understand the diagram properly. Then draw your FBD. Again, no matter how complex I give, the story is the same. Choose your system, draw your free body diagram, apply the forces, write torque equations. This would be a good advanced question. Maybe I'll ask you this as a more than one choice question. This can't be a paragraph. Try. 3 minutes you got. Let's give it a try. Did you guys get the free body diagrams? There, let me show you the FBDs. You check the FBDs whether you got that right. If you mess up your FBD, the whole game is gone. So first the rod guy FBD. There is a hinge, so let's call it ny. There is a nx. You have mg. You have normal reaction here. Let's call it n1. How do you think the friction will be? Left or right? Ask yourself. Look at the cylinder. If the cylinder is trying to go this way, shouldn't the friction be like this on the cylinder backward? So friction here will be forward. So if this is N1, this is F1. Check. Those are the forces on the rod. Now, if you take the cylinder, the same force N1 will be downward. This friction will be F1. This is passing through the center. This is center. This friction will be this way, F2. This will be a normal reaction N2, and this will be your mg. And this angle will be theta. Check how did you get that as theta. There, this is your FBD. You should get this. Now try. I'll give you 2 more minutes. So if you have messed up the FBD, then there's no point. You won't be able to solve anything going ahead. So your FBD must be always proper. And remember, don't write F is equal to mu into N. It is not slipping, so there is no guarantee frictions are maximum. And mu is not given anyways. Anyone not convinced with the FBD, please ask. And why is that angle theta? Geometry, figure it out. If you can't figure out, I'll show you anyways. Did everyone figure out why it is theta? You can extend the line here. This would be 90. If you drop this vertical, this would be 90 minus theta, and this is theta. So they're parallel lines. Theta aa gaya. Step 2, apply force and torque equations. But I think with the torque equation, you can figure out a lot. So if I take torque about the hinge here, torque due to nx, torque due to ny, torque due to F1, torque due to N1, torque due to mg is 0. Nx is gone, ny is gone, F1 is gone. So later on, slowly we'll stop writing this, but okay for now. Mg ka torque is mgl by 2. That must be equal to n1 into L. There, I got n1 ka value already, mg by 2. n1 आ गया तो ny by आ जाएगा. Abhi we need to find f1, f2. Now what? Try. I'll give you another minute. We are doing the whole chapter detailed step by step, right? So in case you had a problem in your classes, you didn't understand, this is the time to learn. So focus, get them done. That's what I'm saying. After every class, resolve these questions. You can see, right? We do it very systematically. The whole purpose is that when you go to the exam, even under that pressure, you should be able to replicate the steps. If it is just about giving you the answer, we can do it any way we want and get the answer somehow. So when you're here for the 2.5 hours, just focus and try to solve and absorb as much as you can. Solve. The time I'm giving you is for you to try. Now for the sphere, when I take, which point do you think is the best point to take? Now your job was to find F1, right? Think about it. Center of mass is fine, Purvaja. You'll get the answer. But there is one really good point. If you take about that point, see how many variables are there? F1, N1 ka value already pata hai. F2, N2. So you have three variables, right? Can you see a point where two variables go off at the same time? If I take torque here, what will happen? N2, F2 will go off, na? Directly F1 aa jayega. Are you getting my point? So you can choose a point selectively such that depending on where you take, you can make your calculations easy. So if I choose this point, the torque, right, my life becomes easy because N2 F2 ka torque will become zero. Directly F1 ka value I'll get it. I hope that is making sense. So from here to here, if you drop the perpendicular distance, this will be r sine theta. This distance will be r cos theta. This distance is r. So basically that's your perpendicular distance to F1. So I'll take torque about point A. You can take about center of mass, nothing wrong. We'll get torque due to N2, torque due to F2. I'll take center of mass also. I'll show you that also. That gives you something else. Torque due to N1, torque due to F1, torque due to mg is 0. N2 goes off, F2 goes off. So I'm more interested in that. I eliminated two variables. N1 ka value you already know. So N1 ka torque will be N1 plus mg. Both are in the same direction. Perpendicular distance is r sine theta. Direction is minus k cap. And the friction cut torque will be, this is plus k cap, because mg will rotate this way about a, that is minus k cap only. And this is f1 into r plus r cos theta. Plus k cap equal to 0. But n1 ka value is already we know mg by 2. So this will be 3 mg by 2. Sine theta is f1 into 1 plus cos theta. There. So friction will be 3 mg sine theta by 2 into 1 plus cos theta. Check. That's your f1. Is that making sense, everyone? How to find F2 and N2? We still have two more variables. Just give it a try. Hmm. Oh, we right, Purvaja. F1 is actually equal to F2. Now, like what Purvaja said, if you take torque about center of mass, you'll get something more interesting. If you take torque about center of mass, torque due to N1, torque due to N2, torque due to mg, torque due to F1, torque due to F2 is 0. This guy is gone, this guy is gone, this guy is gone. All three are passing. You'll get F1R plus k cap. F2R minus k cap equal to 0. We get F1 is equal to F2. There, we got both the frictions now. You're left with only N2. Now, what can we do for N2? You can resolve the forces and solve. NLM तो equation अभी तक use नहीं किया, if you observe. So, if I write the forces in the vertical direction, so in y direction, The forces will be N2 cos theta plus F2 sine theta will balance N1 plus mg. From here I'll get N2 ka value also. There I got everything. Check it out. So choosing this point right is your savior actually. N2, F2, two variables will go off, suddenly F1 will come out. But if you insist like, sir, I don't want to take there, I will take torque about this thing, that is also fine. Take torque about the center, then write the forces in the vertical direction, forces in the horizontal direction. That also will give you the answer. So there's nothing wrong, you will get answers. So when I was solving, that's what it clicked me. I thought, yeah, if I take torque about this N2, F2 ja raha hai. Now exam is sometimes it doesn't click, then it is fine. You just go brute force. Is this clear, everyone? All clear? Next one. It's a good one. So you should definitely try this again on your own. Now from here, I can ask you, find the minimum coefficient of friction, so that the system doesn't slip. That then it becomes really complex. The next part is toppling. So what is this toppling exactly? Now, if you take a block and put it on a floor, you remember how we define normal reaction? It's a force because of the repulsion between the molecules. That means when you say normal reaction, technically speaking, N is not at one single place. N is everywhere on the surface, isn't it? But what we do for convenience, we take the average force, the N is acting at the center exactly. So the entire base, the normal reaction is uniformly distributed. There is no force on the system. Normal reaction is distributed on the surface, and we take N below the center of mass so that it should be in equilibrium. If N and mg are not along the same line, it will rotate. This is fine. So this is how we have been doing so far. We always took N and we solved. But if you apply force on a system, suddenly something changes. So if you take a block and if you apply force F, you will realize, the normal reaction is not same. So you will see the right side of the block is experiencing more normal reaction. For example, see, you're sitting in the chair, try to lean to the right side. You will observe your right thigh has more pressure than the left thigh, isn't it? The weight or the pressure, whatever, shifts towards right side compared to the left side. Same thing when you shift to the left, again, you'll observe the pressure shifts to the left side. Can you feel that? So that means when you are moving left and right, your normal reaction is not at one place. Normal reaction is also moving. Getting it? Now, this we never had a problem in NLM because we always treat it as a point particle. But in real life, when you have blocks and with some dimensions, the normal reaction doesn't stay at one place. So right part of the block experiences more normal reaction. So when you draw a free body diagram, so this is the thing I'm trying to show you. So whenever you draw an FBD, this is how you draw it. Force F, mg will act from the center of mass. Make sure to draw the normal reaction a little to the side. And don't draw it exactly center. And say this distance is x. X is a variable. So depending on how much force you apply, n can be anywhere. That x will take care of the position. Kind of area that is there, but there is a centrifugal force also. That is actually banking of roads we saw. No?
Yes.
So the normal is towards right in this case. So there, this is important. So whenever you draw a free body diagram, always draw this free body diagram. Don't put n below the mg now, right? Now what will happen if you keep on applying more and more force? What will happen? For a certain max f, the whole body balances on the edge. So if you keep pushing more and more and more, the n will keep shifting. And if f further increases, it will topple. So there is a limit how much you can apply before this body will start rolling over. So this phenomena, right, is called as toppling. So when you apply the maximum force, this is your mg. Actually, diagram ऐसा नहीं होगा. N will be to the corner. So this whole thing na, is like this. You're getting? It is just balancing on the edge. The whole weight is just balanced on the edge. It's kind of like, meaning, I know this thing is pretty small. I need to take something more thicker. Let's say something like this. If you take this bottle here, if you see, if I keep pushing force more and more and more, you can see this whole thing, right? I can, at a certain point, you can balance on the edge, and anything more, this will topple, right? So let's say imagine you're standing, and if you see in your chair, if you lean to the right, if you lean, at one point you'll fall from the chair, isn't it? So there, so this is the most important thing. So whenever someone says the body is about to topple, you should draw this FBD. So this is the FBD when the body is about to topple. The N should be on the corner. So the whole body is just standing on that one single line. If it is a 3D structure, the body is about to topple. There, that is the main thing I wanted to teach you in toppling. Other than that, this is also same. Equilibrium, force, torque, all that stuff will be same. We didn't have this problem before because we never cared. For example, see now, in NLM, when I said a block of mass m is placed on a surface, and when I asked you acceleration, what did you say? G sine theta, right? You never bothered to ask me whether did I keep the block like this or whether I kept the block like this. Do you really think both will go the same way? This rod will start toppling, isn't it? We never considered that. So now it would matter. Let's have a look at this page. Let's see a question. Any doubts on this page, please ask. I hope now you're getting the meaning of toppling. So if you sit in your chair, if you lean to the right, if you lean, and someone will fall off. When x is equal to the edge, that is the same thing, right? Clear? Let's see a question on this. So let's say we have a block of mass m. This is 3a. This is a. There is no slipping on the floor. It is not slipping. So it's not sliding basically. And you're applying force F here on the top. So first question, if you apply F is equal to mg by 4, find the position of normal reaction. Where will that n act exactly on the surface? So this is what I was saying. So n you should not put exactly below the center of mass anymore. Second question, find F max so that the body won't topple. Let's get this. 3a by 8. Okay, let's see. Step 1, choose your system, draw a free body diagram. The game is still the same. The only new thing you learned is n won't be in the center. So this f is mg by 4. Mg is the weight. Normal reaction will be somewhere here. Don't forget there is also a friction. It's not slipping, isn't it? There is a friction on the floor. नहीं तो block आगे चले जाएगा. It is not slipping. They won't tell you that there is a friction and all. You need to figure out if it is not slipping, meaning there is a friction on the ground which is stopping it. That's your x there. That's your FBD. If you messed up that f, you're gone. Step 2, write the forces horizontally in the vertical direction. So F is equal to friction is equal to mg by 4. Actually, they both are equal. N is equal to mg. Perfect. We can take torque about any point. I'll take center of mass. Torque due to mg, torque due to n, torque due to friction, torque due to F is 0. mg ka torque is 0. N ka torque is n into x plus k cap. If you see capital F and small f, but they form a couple, but okay, that would be friction into, what is this distance? This is A, this is 3a. So this is f into a by 2 minus k cap, f into a by 2 minus k cap equal to 0. Therefore, I get, what is n? N is mg into x. F and friction are equal. So that would be mg a by 4. So that will, I'll just write it down. So f into a. Perfect. So there we got x is equal to fa by mg. That's your x car result. Now it is given f is mg by 4. So this is a by 4. Make sense? I think most of you forgot that k part. That's the first question. What about the b part? What is the maximum force you can apply so that it doesn't fall? Now see, we already got x ka value is fa by mg. Now you tell me x ka value can be maximum how much? N can go here, here, here. Finally, it can go to this corner, right? That means x ka value cannot exceed this value here, 3a by 2, isn't it? So x ka value must be less than or equal to 3a by 2. Does that make sense? That x will keep increasing, but there's a limit. You can't exceed 3a by 2. So you will get f must be less than equal to 3mg by 2. There. So the maximum force is 3mg by 2. Right, Ishana? You got it. So if you apply 3mg by 2, the block is on the verge of toppling. Anything more, it will roll over. So at this point, n is at the corner. N can go to corner. N can go to corner. So whenever they ask you find maximum f, use that thing. Find in terms of x and then get it. Friction will act anywhere or everywhere on the surface. Why does it matter? Does the perpendicular distance change? Does the perpendicular distance change?
Okay, sir. Understood.
Doesn't matter. It will act everywhere on the surface.
Yes, sir. So about the
When it is about to topple, friction also will be on the corner only. Na? It will be on that line only, edge.
yes.
Is this clear, everyone? Making sense? Toppling questions? So there's nothing there. So the main thing in toppling is the free body diagram. Once you realize that n won't be in the center and you put it little to the x, things will fall in place. It kind of looks like your equilibrium problems, what you have done. Let's see one more. Any doubts? Anything that you're not convinced here, please ask. Next one. But one thing here, when you see this question, how do I know this question is not, loss of motion, but this is rotation? What tells you, the moment you see the question, what tells you, boss, this is a toppling का question? हाँ, question में तो word will be there, that is ठीक है, but no, not that one. There is something there in the diagram. Anyone saw? Right, Ansh. Tell me one thing. Till now, did I ever give you the size of the block? In every chapter before rotation, we never talked about the dimensions of the block. We never cared about it. That is your biggest clue. The moment I give the dimensions of the block, understand boss rotation is involved. Clear? If I simply say a block M is placed on the ground, find F required to move the block, then it is fine. No need to do anything. It is NLM question. NLM friction and all. But the moment I give dimensions, mean understood toppling is involved. So that would be a biggest clue. And then anyway, in the question, there will be words like toppling and stuff. So this is theta, this is mu. We got a block here. This is A. This is B. Mass is M. So the question is, find the condition. I want the block to slide. Means block should slip. Block slides, but it should not topple. Block slides without toppling. You're getting what I'm asking? For example, see, if I take a block like this, won't this fall first before sliding? Yeah, this will topple first before sliding. If I take a block like this will slide. There is a higher chance of sliding than toppling. So you will get a relation between A, B, mu, and theta. So they have to satisfy certain values for this to happen. I can ask the other way also. Find the condition if block does not slide, but it topples. It is the same game. You can play either way. But the question is find the condition if the block slides, but it doesn't topple. Let's get this. Anyone not clear with the question, please ask. Two minutes. Let's see. First, let's see the free body diagram. Start with the free body diagram. That's what I'm saying. Now, when sometimes when you see a question and you're not getting anything, start the free body diagram. The moment you draw free body diagram, you'll start observing things. Things will fall in place. So what are the forces? This is mg sine theta. This is mg cos theta. This is friction. N will be somewhere here. Let this be x. This length was A, this length was B. So first one, you want it to slip. So if you want the block to slip, that means mg sine theta must be greater than your maximum friction. Agreed? If your mg sine theta is greater than F max, then the block will slip. So you will get two conditions. So mg sine theta must be greater than equal to f max is mu mg cos theta. So mu must be less than equal to tan theta, basically angle of repose. This is the condition for slipping. This is to slip. So if you want the block to slip, you have to make sure mu is less than tan theta. Okay. Next thing, for toppling. Now I'll take torque about center of mass, torque due to mg, torque due to friction, torque due to n is 0 because it's not toppling. Mg is gone. Friction ka torque will be F into the perpendicular distance is B by 2 K cap, and this would be N into X minus K cap equal to 0. So we get friction is equal to Nx to Nx by B. But what is N? N is mg cos theta. F is equal to 2Nx by B. It's slipping, right? The F is anyway maximum. So F into B by 2 is equal to Nx. Interestingly, F is nothing but mu n because it slips. Mu n B by 2 is equal to Nx. N will cancel. We get X is equal to mu B by 2. But we know X ka value cannot exceed A by 2. So this must be less than equal to A by 2. So this gives you mu must be less than equal to A by B. This is your second condition, everyone. Making sense? X ka value cannot be more than A by 2. So there. So mu ka value must be less than equal to tan theta. And mu ka value must be also less than equal to A by 2. It should satisfy A by B. So if you satisfy these two, then you will slip, but won't topple. Make sense? Suppose if I ask you, I don't want to slip, but I want to topple, then क्या करेंगे? Reverse ना? Mu greater than tan theta for no slipping, mu greater than A by B for toppling. Make sense? You can play like that. You can just reverse them. So basically, you'll get two independent conditions. Slipping has nothing to do with toppling. So you will get two different things, and you have to see the common whatever is the factor between them. Have a look at this. Clear, everyone? Any doubts on this? Clear? Next one. So there, you know how to calculate torque. Like I said, in this chapter, there are three main things. You should know the basics. You should know how to calculate torque. You should know how to calculate moment of inertia. You should know the no slipping condition. If you know these three things, you have like 80% of the chapter in your hands. So there, this is the first step. Calculation of torque, how to draw an FBD with the torque and all that stuff you have seen. The second part is moment of inertia. The symbol is capital I. So consider a body rotating with angular acceleration alpha. So you take some random body. Now, if this rotates with alpha, if you take a particle here, let's call it mass mi, and if it goes in a circle here of radius ri, we know the tangential acceleration AI is equal to Ri alpha. Remember this from circular motion. This is your tangential acceleration. So from here we get the tangential force Fi is equal to mass Mi into acceleration Ai. Multiply Ri on both the sides, Ri into Fi. This will be Mi. Ri, Ai is Ri into alpha. So Ri into Fi becomes torque on the ith particle. This becomes Mi Ri square into alpha. So you want the net torque. That will be summation of all the torques. This turns out to be sigma Mi Ri square alpha. Do you remember the starting of the chapter we discussed? If the body rotates with alpha, every particle rotates with alpha, isn't it? So alpha will be same for everyone. Mass will be different, radius will be different, but alpha will be same for everyone. All have same alpha. So now if you look at this equation, we can write this thing as torque is equal to I alpha, where I is given by sigma Mi Ri square. Now if you look at this thing resembles F is equal to Ma. So for translation, when you said F is equal to Ma, force is mass into acceleration. Force ka place mein we have torque, right? And alpha ka place mein, A ka place mein you have alpha, and M ka place mein you have I. So moment of inertia plays the same role, like what mass plays in translation. So higher the mass, more difficult to translate the body. Higher the moment of inertia, more difficult to rotate the body. And here, this is the important thing. So Ri is not the position vector. Ri is the perpendicular distance of the particle from the axis. And what is the physical significance? Higher the moment of inertia, more difficult to rotate the body, or more difficult to stop a body from rotating. So whenever you think about moment of inertia, think of like that. If you have a body with a high moment of inertia, it is more difficult to make it rotate. And if it is already rotating, it's more difficult to make it stop rotating. Same thing, whenever someone asks you what is mass, higher the mass, it is more difficult to translate the body. So this is similar to mass in translation. So unlike center of mass, right, moment of inertia is slightly easy because it's behaves like a scalar quantity. There's no y and x coordinate and all that stuff. We will see. Have a look at this. Take a break. Come back with 7.5. Any doubt so far? Okay, come back in 10 minutes. كم ثانية دوم؟ So this is the moment of inertia. Now, if you take for particles, so I is given by sigma mi ri square. Now, if you take for continuous bodies, again, what are continuous bodies? Rods, disks. Moment of inertia I is given by sigma becomes integral. M becomes dm, Ri becomes r square. So here r is the perpendicular distance. So whatever we learned in center of mass, how to choose an element, everything is still valid. Perpendicular distance of the dm from the axis. So for particles, use this m1 r1 square, m2 r2 square, so on. For continuous bodies, you have to integrate this. Now, if you actually see moment of inertia is not a scalar, it is not a vector, it's actually something called tensor. Meaning, think about it. See, for example, if I take this water bottle here, if I rotate like this, right? Or if I try to rotate like this, or if I try to catch on the edge and rotate, isn't it more difficult to catch on the edge and rotate? Meaning, depending on where is my axis of rotation, the moment of inertia is changing. You're getting it? So it is unlike a vector or something, it is not constant in one thing. So it depends on the orientation also. So if you see vector depends on magnitude and direction. So here the tensor is depending even on the orientation. So it's called a tensor. We'll not get into that. We don't have that in the portion. If you do, mechanical engineering and engineering, then you will learn that. But for now, at least in 11th and 12th, we can treat it as a scalar. So moment of inertia, we will simply write this as mi, behaves like a scalar for a given axis of rotation. So if you take one axis of rotation, and if you ask moment of inertia, I can just add it like a scalar. So if you change the axis of rotation, moment of inertia also will change. So this thing, moment of inertia, is a tensor. There. Yeah, let's see our question on this. So this is your axis of rotation. This is m. This is 2m. This is 3m. This distance is d. This distance is 2d. This distance is 3d. Easy one. Same thing. You have m. This distance is d. This is 2m. This distance is 2d. This is 3m. This distance is 3d. Find moment of inertia. Yeah, this is straightforward question. Meaning you just. So I is equal to m into d square. 2m into 2d whole square. 3m into 3d whole square. So this would be 36md square for both of them. So here we have an important statement here. That means moment of inertia doesn't depend on the orientation of the particles. Means you keep the 2m anywhere on the circle. As long as you keep the distance same, moment of inertia same, isn't it? Whether you keep the particle to the left, right, front, back, as long as you keep the perpendicular distance same, you can keep it anywhere you want. Quite a useful statement, saves you a lot from integration later on. So moment of inertia is independent of orientation of the particles. And depends only on the perpendicular distance. As long as the perpendicular distance is same. Clear, everyone? Next one. This is X, this is Y, and this is Z. We have a particle here M. This is X comma Y comma Z, some random particle there. So find the moment of inertia about x-axis. So sure, x-axis is the axis of rotation. What is the moment of inertia? About y-axis, about z-axis. So this is important. Someone asks you what is moment of inertia. First thing you should ask, about which axis are you talking about? What do you mean by x-axis? So if this was your x-axis, it is rotating about this circle. You're getting? When I say y-axis, it's rotating about this circle. When I say z-axis, it is rotating something like this. I hope you are getting how it is. Depending on the axis of rotation, plane of rotation will be perpendicular to it. Get this? So question is easy, but the result which we get is important. We're going to use it again in electrostatics. Yeah. Again, remember, r is not the distance from the axis. It's not the distance from the origin. It's the perpendicular distance. It's more of a geometry. See, what will I do? I will draw a line parallel to the z-axis and passing through the particle. Okay. So if you take this point here, now see this point coordinates are x comma y comma z. If you bring it to the xy plane, what will happen to the coordinates x comma y comma 0? Agreed? If you drop a perpendicular onto the xy plane, you'll get this, and this coordinate is 0 comma 0 comma 0. So if you take this distance here, this will be a root over x square plus y square. Now you tell me, if I move this line here, will the distance change? Will this distance change? the perpendicular distance will not change. The distance between two parallel lines will remain same. So whenever you want perpendicular distance from z-axis, ignore the z coordinate. So that this is the thing you can remember. So if you want perpendicular distance from x-axis, x coordinate is useless. So when you go parallel to a particular axis, that coordinate won't matter. So root over y square plus z square. If you want perpendicular distance from y-axis, ignore the x coordinate, y coordinate, x square plus z square. Perpendicular distance from z-axis. This formula is important. Huh? This we will use again. X square plus y square. There, you're done. So moment of inertia about x-axis will be m into y square plus z square. Moment of inertia about y will be m into x square plus z square. There, easy question, but should know. Perpendicular distance ka formula. Is that making sense? So whichever axis you want, don't take that coordinate. So be careful. R is not the distance from the origin. So unlike center of mass, right, particles are actually easy in moment of inertia. There's nothing there. M into R square, you're done and you'll get it. The next thing is continuous bodies. Any doubts on this? All clear with the perpendicular distance part? Next thing. Now in continuous bodies, the first shape we'll take is a uniform rod. So we have a uniform rod. So let me show you one. So we have a rod here, mass m, length L. I want to find the moment of inertia about the central axis. So this is how they'll show the diagram. They'll just give like this and say find moment of inertia. This is x is equal to L by 2, x is equal to minus L by 2. Now this I taught you in center of mass. Whenever you see a rod, how do you choose an element? At a distance x, take a small slice. So this is how you choose elements. So for this small slice, dm will be total mass of the rod by total length of the rod into length of the small piece, unitary method. Mass per unit length into dx. And what is the perpendicular distance here? Here the perpendicular distance r is x. So this dm is at a distance of x from the axis. You're done. So moment of inertia formula is integral dm r square. So dm is m by L dx. R is the perpendicular distance x square. X ka values are going from minus L by 2 to L by 2. Substitute there. This will be m by L x cubed by 3. Limits are from L by 2 to minus L by 2. This is ml square by 12. So if you take a rod about the center, the moment of inertia is ml square by 12. You need to ratify these results. Exam you won't have time to derive. There are some standard results which we will be doing. You need to mug up them. Clear with this? How I did this? Check out this. All clear? Now you guys try. Similar one. Rod is there, but this time it is about the edge. Mass m, length L. Same thing, but this time the rod is like this. This is theta, mass m, length L. Meaning this rod is rotating like this. You're getting how it is? The rod is tilted like this, if you see my screen here. And it is rotating like this. When it's like someone is catching a pen like this and you're trying to rotate it at an angle. Get the moment of inertia for that rod. Same thing if the rod is like this. M and L, theta. This rod is trying to rotate like this. I hope the orientations are clear. Get the moment of inertia for these three. Try. First one is easy. Get the remaining two also. I'll give you a minute. Yeah, most of you got the first one. That's the standard result. Yeah, first one is easy. Second one, C and D. Give me that I'm interested in. Look at the first one, B bar. Same story. At a distance x, take a small slice. So it is same as the previous one. So dm will be m by L dx. So the moment of inertia will be integral dm r square is integral m by L dx x square. The only thing that changes limits. Now x will go from 0 to L. So we get I is ml square by 3. Bas. Previous question it is going from minus L by 2 to plus L by 2. Now L is going from 0 to L directly. What about this guy? 24 नहीं आएगा रे, थोड़ा ज्यादा आ गया शाना. Remember, whenever you have a rod, you always have to cut the piece like this only, meaning x has to be like this only. You can't take x horizontal or something. X is the length along the rod. You can't cut the rod, like this pieces. This is not a symmetrical pieces. You have to cut it like dx ka pieces like that only. So if this was the rod, look at this. So at a distance x from the center, we will take a small slice dx. Story is still the same. Now the only difference is if this is angle theta, what is r? R is the perpendicular distance. This is r, which is x sine theta. Making sense? R is not the distance from the center. R is the distance of the particle from the axis. So now your formula I integral when you say dm r square, this will be m by L dx. R ka place mein you'll get x sine theta ka square. Remember theta is constant. Limits are minus L by 2 to L by 2. So you will get ml square by 12 sine square theta. If you put theta is equal to 90 degrees, it becomes your first part as the answer. Check it out. It's ml square by 12 sine square theta. Be careful, theta is the angle with the vertical. If they give you angle with horizontal, it will become cos square theta. So don't blindly mug up sine square theta, understand which angle we have taken. If I use the same logic here, you will get the same thing. This is the axis. Same story. This is dx. This distance is x sine theta. The only difference limits will be 0 to ml square by 3 sine square theta. Check. So C and D kind of look like A and B. Only difference is extra sine square theta. Is this clear, everyone? Any doubts on the integration part? So always, no matter however is the rod का orientation, x is always along the rod. Just because the rod is like this, you don't take x like this. X will be always along the rod. Element will be always dx like this only. What changes is r ka value. What about this guy? This is axis of rotation. We have a rod parallel to this thing. M and L. This is D. The rod is going like this. It's parallel to the axis. Let's say lambda is equal to lambda naught x square, non-uniform rod. This is a rod bent into V shape at center. And if you see the top view, this is your axis. This is how the rod will be. Meaning this piece ka length is m by 2, L by 2, m by 2, L by 2. What about these three? Yeah, E is easy. I is equal to simply md square. Why? Every point on the rod is at a distance t. Or even think about it. If I take the rod and compress it like a point, did the perpendicular distance change? No. As long as the perpendicular distance doesn't change, it doesn't matter. So all points are at a distance d from the axis. So it is md square. What about the non-uniform rod? Get it? Mm-hmm. But you want to find center mass. You have to find moment of inertia. You don't need to do that. F is lambda power 5 by 5. Yes, power 5 आएगा. Yeah, that was easy. Same story. Distance x, we take a small piece dx. This time the difference will be dm will be lambda into dx, which is lambda naught x square dx. The moment of inertia will be dm, so lambda naught x square dx into x square, 0 to L. That would be lambda naught L power 5 by 5. This is your dm ka term, the one in the green box. बस सिर्फ लैम्डा का प्लेस में चेंज करना था. G is an interesting one. You're getting how? What did I do? It's like see, think of like this. So if this is the rod, right? This is the rod. You bent it like this. You're getting it? The rod which was like this, you bent the rod into a V shape. It is in the same plane, but the rod is bent. The top view looks like this. The side view looks like this. Then what is the moment of inertia? If the angle between the two bent pieces is theta. Anyone not clear with the J diagram, please ask. नहीं पूरा. Tell me one thing. For the G part, when the rod was like this, okay, top view, I'll show you the top view. This was the axis, okay. So if you consider some point A here, and if you consider some point B here, let's say this distance is some RA, this distance is some RB. Now, when you bent this rod into a V shape, this is your axis. This point is A. Did this distance change? Did this distance change? You getting what happened? When you stretch your hand, right, and when you rotate, does your distance from the elbow to the shoulder change? So the perpendicular distance from the axis remains same, isn't it? The perpendicular distance from the axis for any point on the rod does not change with bending the rod. Perpendicular distance from axis does not change by bending the rod. It is independent of theta. Think of like that. You stretch your hand and rotate your hand like on the plane, right? No matter how much you rotate in the plane, the tip of your hand to the shoulder distance won't change. The distance from the elbow to the shoulder won't change, isn't it? Is that making sense? Therefore, moment of inertia will remain same, ml squared by 12. Is that making sense? Right? Even you can club both of them like this. Make a rod of double thickness. Mass m, length L by 2 हो जाएगा. It doesn't matter. Answer is still same. The perpendicular distance from the axis doesn't change. Make sense? So that's what I'm saying. You should be clear about like as long as you keep the distance same, do anything you want, the answer will remain same. Any doubts on this? Clear? Next one. Next one. The next shape is an arc. This was easy. So if you have an arc, theta, mass m, radius r. If you look at the side view, it would look like this. This is the side view. This is the top view. What is the answer for this? All the points are at same distance from the axis, right? It won't matter. I is mr square. All points are at same distance. This is what I was saying. Once you know that it matters only on the distance, you can eliminate a lot of integrations. And this thing gives you even something more interesting. That means if you take a ring of same mass, and if this was the axis passing through the center, so I of the ring passing through the center is how much? Mr square. You can do even something better. If you take a hollow cylinder, and if you rotate about this axis, M and R, this is also Mr square, isn't it? Because if you take any point here, the perpendicular distance remains same. Think of like this. If you take a hollow cylinder and if I compress this, won't I get a ring? If you take a hollow cylinder and compress, you will get a ring. The perpendicular distance doesn't change. So if you take an arc, or if you take a ring, or if you take a hollow cylinder, all have same moment of inertia. There, that is the statement we are using. As long as you keep the distance same, you do anything you want. You can stretch that arc into a ring, then you can stretch the ring into a hollow cylinder. It doesn't matter. All should have same mass and radius though. Is this clear, everyone? Arc was easy. There is no need to integrate or do anything. Clear? Any doubts on this page? Please ask. Ojas, clear, na? Vignajit, Soham? Clear? Next thing. What about a disk? Disk passing through the center. I will give you the answer, but let's derive and see. The answer is mr square by 2. But how do we derive this? You need to know the derivation, because tomorrow what they'll do now, they will say we have a disk whose density is sigma naught into r. It's a non-uniform disk whose mass is changing. Then you'll get stuck. You should know how to integrate. And also this is there for HSC 12th standard ka board exam. It's a derivation. Unlike a ring where it was easy to see, disk is not that easy. So you have to integrate a bit. Get this? Again, remember how to choose an element for a disk. See how to choose an element. So whenever you have a disk, now this is what I'm saying. For everything, the techniques are same. Mr square by 2 I wrote the answer, Pratik. See, the moment you see a disk and you have to integrate, this is the general thing. At a distance x, take a thin ring. Whose width is also dx. There. So this is how the ring will be. This radius is x, this thickness is dx. Now cut it. If you cut it and open this, you will get a rectangle whose length will be 2 pi x, whose width will be dx. So for this thin rectangle, we will get the area, small area is length into breadth. So the mass of this thin ring will be total mass of the disk by total area. So this is your surface density into area of this ring, which will be 2mx dx by r square. And we already studied in the previous one, the moment of inertia of a ring is nothing but mass of the ring into radius of the ring ka square. So this would be 2mx dx by r square, and the radius of the ring is x square. So if you want the moment of inertia of the disk, and we take rectangles from axis to circumference and integrate. Wow, you have a great imagination. So you are saying you'll make rectangles like this. These are rectangles.
No, sir, but like
Uh-huh.
exact
So you will
width.
get rectangles like this, and you'll get holes in the gap. Next time when you go to Domino's, order them a pizza made of rectangles in a circle. And imagine they give you a pizza like this. Just imagine chocolate ka bars like this. You will take this pizza, you'll punch him and say, what the nonsense is this? You will take slices, isn't it? You will get non-union rectangle nahi hai, sectors hai ye.
Yes, sir.
You have to be uniform, na?
Yes,
So
sir.
moment of inertia of the disk will be how much? Integral I of the ring. So you have to integrate all the ring ka moment of inertia. This is 2m by r square integral x cube dx. Limits will go from 0 to r. That will be r power 4 by 4. So m r square by 2. Check. Now, if they give you in the question, density is changing sigma naught x, what will change in the answer? Where will I change this? In place of this one here will come sigma naught x, na? Surface density. That's it. That is where it will change, and everything else will remain same. That's what I'm saying. You should know how to choose your elements. The actual integration is easy, x power n. The headache is always choosing the elements. Have a look at this. You're getting now, Vivan? You can't take elements like that.
Yes, sir.
You can take sectors though, but sector का moment of inertia idea नहीं है. All clear with this? Any doubts on the integration? Now, based on this, we can clearly see, suppose if you have the axis and if you have a sector, basically pizza ka slice, same mass and r, theta, or if you take a full disk, mass m and r, or if you take a solid cylinder, mass m and r, all have same moment of inertia, mr square by 2. How did that happen? Think about it. If I take this sector here and if I stretch it, by doing this, you're getting what happened. Do you know the fan you have now? When you stretch this thing, you'll get a fan, like a peacock of feathers kind of thing. So when you stretch this, right, did the perpendicular distance change? So this point, if I stretch it into a circle, is the distance changing from the axis? So I can stretch this sector into a disk. It will become thinner, but the perpendicular distance does not change. Is that making sense? So as long as the mass is same for a sector, for a disk, or for a solid cylinder, all have same moment of inertia. Please have a look at this. This statement, if you're not clear, please ask me. We cannot make use of the moment of inertia ring somewhere to move. Arey, we used it, na re God. ये तो क्या था? हाँ, Arya.
Okay, sir, got it.
We did use it, huh?
Yes.
Is everyone convinced why sector also behaves like a disk? Real life mein what happens, if you take a sector and a disk will have more mass in real life. So, but that's what I'm saying. If you have a sector and a disk of same mass, they have same moment of inertia. How is the moment of inertia rod and disk not same? Why will moment of inertia rod and disk will be same?
Sir, because if we extend the rod like in a circle, then it will be uniform everywhere, and the
You
distance
will
will
get
also
a non-uniform rod. Okay, let
Oh,
me show you. Chalo, let's say we go to a pizza shop, right? And we order a slice of pizza. Okay, we will divide equally, huh? So we will compress this pizza into a rod, like you said, right? And we will cut it into equal piece. I will take the upper piece. You take the lower piece. Try this with your sister or brother and see what happens. Means you know what you did? You cut it here and then you compress this, isn't it? Will you get a uniform rod? If you still don't believe, try this with your sister and see the fight. You will get a non-uniform. If you compress a sector, you won't get a uniform rod. I hope you're getting it. Why you can't make a disc into a rod? Yeah.
yes, I got
So the thing is that you won't get a uniform thing. You're compressing more mass on one side. Is this clear, everyone? Got this? So this is what I was saying. Unlike centromass, this thing is little easier. As long as you keep the distance same, it saves you a lot of time from integration. Centromass was more dangerous than moment of inertia because there we had to find x coordinate separately, y coordinate separately, and a lot of mess. Yeah. Next one. Suppose if you have a right-angled triangular plate. Right-angled triangular plate uniform. If I don't mention anything, assume uniform. If it is non-uniform, I'll give you something. This is your axis. So basically it is rotating about the base. This distance is B, this distance is H. Mass is M. Find the moment of inertia. Are you getting how am I rotating? It's like, for example, see, this book is there and it's not a triangle, but if this was a triangle, this is how it is rotating. You're getting how it is rotating? So it's rotating about the base like this. Oh, school ka protractor box, you get that, na? Triangle thing. So if you catch that on the base and if you try to rotate, this is what it will look like. You have to integrate. There is no way to figure it out. So think like how will you choose an element and then now just to give an idea, there are two ways you can choose this thing, but I would prefer like this. I will take thin rods like this. So I will choose thin rods like this, and then I know the moment of inertia for thin rods, and then I'll add it up. Think I'll give 2 minutes. Try to figure out the main parts. You can take like this also, but I don't like this. This will be mathematically little complex, but that can be done. I would prefer these rods. Like this, at a distance x, take a rod thin dx, and then try. There, I gave you an idea how to start. Near Shana, you're close by. No, the denominator may it is not 2. Everything else is fine. 2 का place में you'll get some other number. Let's see. Now, these kind of questions, right? It doesn't strike. Sometimes you should have seen these kind of things at least once. Then it becomes easy in the exam. But at least, by doing multiple things like this, you'll start getting a hang of how to choose elements. So from here at a distance x, we will take a thin slice. Now, technically speaking, that's like a trapezium, but dx is so small, you can neglect the top part. That's the whole point of integration, if you remember. Now, if this is theta, this length will be x tan theta. And what is tan theta? Tan theta is h by b, the height by base. So there. So we got this thin rod. This is your axis of rotation. This thickness was dx, and this was x tan theta. So it's a small rectangle. Daksha, you didn't, did you type wrong here? Instead of m, did you type a square?
Sir, it is H, I think.
But mass नहीं है तेरा term में. How did you mode differentiate without mass? Nikhil, Nikhil, that is wrong, right? What is A, Nikhil? A तो दिया ही नहीं. How are you guys getting variables which I didn't give you? Question में H है, B है, M है. A कहाँ से आया? Okay. That is, that is right then. So the area of this thing will be length into breadth, which is x tan theta into dx. So for this small piece, what is the mass? Total mass of the triangle by area of the triangle of BH. This is the surface density into dA. So this will be 2m tan theta x dx by BH. This is your mass. And just now we saw moment of inertia for the rod is m L square by 3. Remember, we proved that there is a case 2 in the rods. So this is dm 2m tan theta right here. So m ka place may we have 2m tan theta b h x dx. L ka place may we have x tan theta ka square by 3. So this was the length of the rod. It looks dangerous, but let's see. And then this is 2m tan cube theta x cube dx by 3bh. This is for the rod. Now, if I add all the rods, I will get for the triangle. That would be I of the rod, which is 2m tan cube theta by 3bh integral x cube dx. X ka value will go from 0 to b. Then 2m by 3bh. What is tan theta? H by b. So that is h cube by b cube. And what is that? That is b power 4 by 4. B cancels everywhere. One h also will cancel. You will get mh square by 6. You get a pretty nice answer. The answer is independent of the base, but you can do something more better than this. But have a look at the integration. That means as long as you keep the triangle ka height same and the mass same, doesn't matter how long the base is, answer remains same. We proved it. It's like there is no way to see the question and guess that. Because one way you can say this thing, end of the day, what matters is only the perpendicular distance, right? The horizontal distance doesn't matter. That's why B didn't come in the answer. That is one way you can say. Is this clear, everyone? But let's make this result even better. This is a standard result. You can remember this. I'll turn the page back again. So if you have a scalene triangle, and let's say this height is h, mass is m, I can split this triangle into two pieces. one piece like this, mass m1, height h, plus I can split the second piece like this. So scalene triangle can be split into two pieces, unequal masses, height h. This moment of inertia is m1 h square by 6. Just now we proved for the right angle triangle. This is m2 h square by 6. So I will be m1 plus m2 h square by 6. But m1 plus m2 is the total mass. So this result is actually valid for any triangle. Remember, this is I about the base. So the moment of inertia for a scalene triangle about the base is mh square by 6, independent of b. Again, uniform plate. Of inertia about base depends only on the height. There. So this you can apply even for a scalene triangle. Right angle triangle is fine. So, but that would be your final result. Mh square by 6 for a given base. You're getting how we proved from right angle triangle to scalene triangle? Because you can split the scalene into two right angle triangles. Mass m1, m2, agree, both are different. But when you add m1 plus m2, it becomes total mass. It's a pretty good result. Is this clear, everyone? So there, so even in moment of inertia, right, we have one problems like this based on integration and stuff, and then we also have two theorems called parallax theorem and perpendicular theorem. Those will be, those will actually save you time, save you from integrations in certain things. So those things we'll be doing more in the next class. So next class we will be doing more integrations. We will take, solid sphere, moment of inertia, hollow sphere, all those stuff integrations we'll be doing, and then we'll put down all the main results, and then we'll also study, the two theorems also. There is perpendicular and parallax theorem. So mostly next class we will be focusing more on moment of inertia, and if time permits, maybe we will do no slipping condition ka little introduction, right? So Thursday when we catch up, we'll continue from here. So yeah, I think with that we'll wrap up for the day. So do make sure to resolve. We have done almost 18 questions. Again, I'm telling you, whatever I taught you, if you don't do it today before sleeping or maximum tomorrow, you will forget, right? After 4 days, when you open the notes, everything will